Hello, my name is Evan Schwartz, and we're going to take a look at the GPS solution, depth perception. We just got a chance to look at the screencast of me walking out in my yard, nearly killing myself. So this is basically the Unity project. There's two key components. There's the player component, which in this case is the ball, and then there's the candy. And the only scripts in play are the player scripts, and this is just syntactical sugar for me to easily access some of the UI labels. Nothing really special there. And then on the candy, similar thing, the candy keeps up with the score and keeps up with the collision. So let's take a look at the code. So, looking at the player scripts, everything happens within the player script. So this is just all of my helper. This is keeping up with the labels, being able to output. This is all my helper mathematics. So I need to be able to center the player's virtual location with a pinpoint in the GPS location. So what happens is I get a base location and tie that to the player's current transform X and Z position, and then these would be my ongoing deltas as I'm moving away from that position. I tried doing something interesting with lerp so it didn't look so jerky, but the GPS it didn't work out, so those are some legacy holdovers. I had originally started using the input location, which is built into Unity. Went through the whole build out. The problem is that Unity's precision is so light, I mean, it's so weak that I would literally have to go almost 20, 30, 40 yards before it would register a single change in my GPS location. So I found a package on the asset store called Acura GPS, and essentially they get down and use doubles rather than floats, which gives me the GPS string coming right out of the native device, which is what I needed to do this type of game. Is I needed something with a little bit more precision. I got Xcode jumping on me. No code. Get rid of that. All right. So essentially, though, it runs the same way. I want to make sure that it's enabled. Some of the key things is making sure that all your permissions and stuff are set up. Something I was a little disappointed in is that Unity's player settings didn't have all the necessary permissions to get GPS and location services working on an iPhone. I actually had to go into Xcode and set up my own pinfo and configure it for it to work. Otherwise, it will not prompt you to allow this application to use location services, nor is there any way to turn it on. So if you deploy it without both always on and on while playing, you just can't use it on an iOS. So that was really the trickiest part, is trying to figure out what the permission requirements were to get it to turn on. But once you've got it on, it's like I said, it's just like the Unity um, native calls from input. You just call the Acura GPS start. That sort of kickstarts everything. And then we just initialize. I grab the player. I want to get the original, what's the origin spot for the player. And then this again was me trying to do a lerp thing that ultimately it was too jerky. The velocity wasn't consistent, so there was just no way to do it. This is my do center button that puts the ball back where it belongs. This is my on quit event that stops GPS. As you can see, here's the original Unity input stop, and then this is the native package that essentially the only difference between these two is Acura GPS returns a double and Unity returns a float, which isn't as precise. This is just my little helper function using the ellipsis to make sure that I can accurately test equality between floating point values. This is my failed lerp routine. It just wasn't smooth. So in the updates where all the magic happens, so the first thing I want to make sure is that if the base latitude is sitting at 0, it means it's uninitialized. Then let's go ahead and grab the first GPS coordinate, and what we'll do is we'll assume that the player's is in that spot, and let's put the ball over that. So we're sort of overlaying two coordinate systems and trying to come to an agreement that where the ball is equals what the player's current GPS coordinates are. Now, after playing with it, there's a little bit of a spin up. So once you start the application, you would have seen that in the screencast. As it's contacting out satellites and things, trying to figure it out, it's all over the place, right? So it takes a little bit of spin up time. That the center button solves that. So once you realize that the accuracy kind of settles down, you hit center, and resettles everything, and everything lines up the way you want it. So at this point, all you're really doing, the whole salient piece of this code, is just to grab the lat and long. So these become my deltas. I'm outputting these just so I can see what's going on. But essentially, the crux of the code is I'm taking my base latitude, my starting position, I'm subtracting from my delta. I'm multiplying a speed factor because I'm trying to overlay. This is just a scaling. This might as well just been called scale, right? It's a scaling factor so that I can move my guy reasonably on my plane without it being so tiny movements that you'd have to drive miles to get the first piece of candy. And then what it's essentially doing is it's delta or offsetting the original coordinates of your player by that amount. And then you end up getting your delta values. I output those again just to see what it is. This was the LERPing thing, didn't work out. And then I set my player's position, and I could have combined these, but I just wanted to demonstrate the point is once I set the position, then I clamp it to keep it on a playing field because during early testing, the GPS wasn't sure what the scaling factor was, and it was sending the ball all over the place. So this at least kept it in the playing field for me. And this is my little cheats so that I could test scoring inside the Unity editor. I just put some keyboard controls in there. On the candy, it's a single collision. I'm just checking to make sure that the tag is a player, and if so, I'm getting what the current score is. I'm adding 100 to it, adding that back to score, and then I'm destroying the object to make it go away. So nothing magical there. So in short, this is a pretty short and sweet game, but you could see real easily how you could leverage a GPS data to make a game. I still think it's a little dangerous to have someone wandering about looking at their phone rather than where they're going. So, anyway, I hope you enjoyed it, and thank you for your time.